Hello guys, over to the new problem on oscillations. A particle of mass 50 gram executes SHM along a path of length 20 centimeter. Okay, at the rate of 600 oscillations per minute. Find its energy. Okay, that is the first part. Now what is the second part? Also find its potential energy and kinetic energy at a point midway between the mean and extreme position. Okay, so now let us understand what is given here. They say the mass is 50 gram. Okay, so let us write down. My data is mass is equal to 50 gram. So it's always better to convert your data, given data, into SI units. Okay, 50 into 10 raised to power minus 3 kg. Fine. Path length is 20 centimeter. See, it is path length, it is not amplitude. Okay, my path length is, this is my mean position O, so I go here and then I go here. So P and Q, I go from O, I go to P, P to O, O to Q, and Q to O again, correct? So this total length of path is 20 centimeter. So that means your amplitude is half of that. So I would write A is equal to 10 centimeter. So that would be equal to 10 into 10 raised to power minus 2 meter. Correct? That is given. What else is given? At a rate of 600 oscillations per minute. So frequency of oscillation F is equal to it is 600 oscillations per minute. So I want oscillations per second, correct? So that would be equal to 600 over 60 oscillations per second, correct? So that is equal to, again, it would be 10 hertz, correct? So frequency is 10 hertz, right? So now if you know F, if you know the frequency, you know angular frequency, correct? So my omega would be equal to 2 pi into F, and that would be equal to 2 pi into 10, that would be equal to 20 pi radian per second. Okay, now they want you to find the energy. Okay, so first part would be energy. So when they say energy, you can take it as total energy. Okay, because total energy is going to remain same, right? So it is going to be half k a square. Now what is k here? K is m omega square. K is a force constant or maybe spring constant of the system, and that would be equal to m omega square here into a square, right? So half into mass is 50 into 10 raised to power minus 3 into omega square. Omega square would be equal to 400 pi square multiplied by square of amplitude. Your amplitude is 10 into 10 raised to power minus 2. So that would be equal to 0.1 meter. So 0.1 square here, correct? So it would be 50. So now if you cancel this 2 here, this 2 will get cancelled with this 400. So 200 into 50, that would be equal to 10,000 upon 100 into 10 raised to power minus 3 there, and then that multiplied by pi square. Now obviously pi is 3.142, and pi square would be something it would be something near to 10. Okay, so if I have to approximate, I would go ahead with that. But then here what you can do is you can use your calculators or any other means of calculation which you are allowed in your exam, and get this answer for total energy, that many joule, correct? So that was the first part. Now also find its potential energy and kinetic energy at a point midway between the mean and extreme position. So that means, see, my amplitude is 10 centimeter, correct? So I want to find KE and PE at x is equal to a by 2, correct? So my a is equal to 10, so that would be equal to 5 centimeter, that is 5 into 10 raised to power minus 2, correct? So now I'm going to use this black now, so that you would be able to differentiate here, okay? So my Ke would be half m omega square into a square minus x square. So you substitute for amplitude as 10 centimeter and your x as 5 centimeter here, okay, and you get your kinetic energy. And what about potential energy? Pe would be equal to half m omega square into x square. So now here you'll be substituting for mass and omega, and for x you'll be substituting here 5 centimeter or 5 into 10 to the power minus 2 meter, and get this answer as well. Okay, you can do these calculations and get the answers over here. In the next video again we'll be dealing with some problems on oscillation, probably simple pendulum. Thank you so much.